Hello guys, welcome to Quality in Welding Methodology. Today we are discussing on root path welding of pipe without backing as per American Welding Society. Introduction. When the pipe system designer had determined that the use of backing ring is unacceptable and that complete joint penetration and a continuous root surface is needed, but joint may be made from one side without backing. Use special group design and technique described in this document. Although gas tungsten arc welding GTAW commonly used for pieces control in root path welding, shielded metal arc welding SMAW and gas metal arc welding GMAW are also widely used to achieve complete joint penetration and accept root surface. Cleanness. Cleanness is important in all welding. And it is especially so in root path welding. This including good face and groove face and a minimum of 1 inch from groove and on both sides and the outside surface of the pipe. Grinding or other mechanical means should be used to remove all paint, scale, rust and dirt. In addition, all part of the joint should be free of grease and oil. This may be removed by use suitable solvent. A suitable solvent is one that does not have a residue and is not harmful to the welder or the weldment. Most solvents require good ventilation and many inflammable. Therefore, proper precaution should be taken. Grinding and cleaning operation should be done just prior to welding. After cleaning, the pipe should be handled with clean glue or pressure cleanliness. Preserve cleanliness. Sorry. Preparation of purging. The highest quality root welds are obtained by using GTAW either with or without consumable insert. A purge displacement of air at the inside surface of the weldment with a suitable gas. It is required for stainless steel and non-ferrous pipe system, except aluminium. If the smooth root surface to be obtained, carbon steel and most low-alloy steel can be welded using an upon root groove without the use of an internal gas purge. Purging of joint with consumable insert reduce the occurrence of defects resulting of oxidation of the insert. Purging will also increase welding speed. Purging gas. Welding grade argon is the gas most often used for internal purging. For some applications, nitrogen, carbon dioxide, helium, and mixture of this gas are suitable purge gas. The gas can be used at lower cost than argon for special application, but they should be demonstrated as suitable by testing period to use in production. The period to purging gas is important should be including the welding procedure specificity. Argon, helium, and nitrogen of better than 99% of purity are available, commercial, and should be used. The moisture content should be controlled by specifying the dew point of minus 40 degree centigrade maximum. The purging procedure described in this document are based on the use of argon as the purging gas. If nitrogen or helium is used, modification to the purging procedure may be necessary because both gases are less dense than air and argon. Purging requires entrance and exit opening through which the purge gas can enter and leave the weld joint area control rate. For piping, where both ends can be kept properly sized wood or plastic disc can be tapped in the pipe in. Plastic caps that are used to prevent damage and pipe in during shipment and are commonly used as part caps. The caps can be entrance side required the hole receive the purge gas. The other cap requires a hole large enough to prevent the buildup of gas pressure. Since air is light than argon, the exit hole should be at a higher elevation to minimize the entrapment of air. Precaution should be taken to be ensured that all track parts are blocked and the branch, pipe and other area where there may be entrapped are well vented. But caps of the type discussed here are most commonly used when a large portion of the system or an entire system is purged. Other purge containment techniques are available for situation where purging the entire system is impractical. One of these this is used for water soluble paper from which dam can be formed to contain the purge gas. This commercially available dam are in the form of water should be paper dish that can be fastened inside the pipe on both the side of wall joint period to assembly. The deck should be approximately 6 inch to 12 inch from the weld joint. From small diameter pipe for tubing, the soluble paper can be crumped to the approximately inside the diameter and stuffed into the pipe or tube, thus eliminating the need for tapping in the plates after welding. The dish can be dissolved with a water rinse or left into the dissolve during hydraulic testing. Sorry. Soluble damp, soluble damps are practically advantages. Soluble damps are particularly advan- advantageous because they reduce the volume of air which must be purged on large pipe system. It is important that the water should soluble damp material to be located far enough from the well to prevent it from overheating or burning. When the weld pipe be post-well heat treatment, cardboard discs held in pipe with masking tape are suitable since they will burn to ashes during heat treating. Hinge collapsed or rubber gasket dish of the type showing the figure one also be fabricated and fit into piping. The purging technique are similar to those used with soluble damps. At last, one end of the pipe system must be left open the removal of the dish after welding. Part gas containment showing here. Commercially available filter bladder can be also be used as a localized per containment. When an opening is available to remove the bladder after welding, one bladder is inserted on the each side of the joint to be welded. The bladders are inflated with part gas or air. After this purging can pursue the described previously. Purged dams should be far enough away from the groove to prevent burning, molten, melting, or other damage to be damped from that of welding, typically a distance of 6 inch in adequate. Whenever preheating is used, the distance should be increased to keep metal temperature at the dam no higher than 300 degree Fahrenheit 150 degrees centigrade. Care should be also be taken when removing dam that would be area is cool enough to prevent heat damage to bladder or the rubber or plastic type of dam. In addition to sealing the branch connection and opening of the pipe, it also necessary to prevent the pudding gas from escaping through the root opening at the weld group itself. This is commonly done by wrapping a single layer of tape around the outside of the joint. The shade, the tape, the tape should not be touched with groove face. It should not be leave residue after removal. Care should be taken to sell off of lack of path before introducing the purge gas into the piping system. All root opening in the system within the purge gas exit and entrance point should be taped closed. All branch pipe and other area where air can be become entrapped should be vented. Piping system is a two-stage operation. During the first stage, period to welding, the purge gas is used to displace the air and the pipe relatively high flow rate. This high flow rate is maintained until the gas inside the pipe is reach an acceptably low oxygen level. During the second stage, the purge gas flow rate is reduced that the part maintains the side positive pressure on inside the pipe. The reduced gas flow is maintained while the root pipe is welded. Eliminate air re-entry into the pipe and minimize the oxidation of root surface. The time required for the first stage is purging depends on the maximum oxygen level permitted on by the welding procedure, the volume of the system being purged, and the purge gas flow rate. However, the relationship between purge gas flow rate and time is not linear. Like a system that can be purged in 1 hour at the flow rate with 50 CFH, 25 liters per minute, will not be purged into some degree in the 1/2 hour if the flow rate is increased 48 liters per minute and increase the purge flow rate increase the turbulence with the system, with result in increase the maximum of air and the purge gas. This will be required addition volume change of gas in the pipe to achieve the desired level of purity. At the lower flow rate, less mixing occurs and heavier purge gas force the air upward and out of the pipe system. Right. Higher purge flow rates will be decrease the time required for the rebuild purging. but increase the amount of the gas required. In general relationship, pre-built flow rates and the time can be arrived at the form in simple and the form simple calculation of the system volume and applying the time factor. The time for one volume change of the system is found by dividing the volume by the per gas flow rate. For example, the pre-purge time for one volume change in the 20 feet 6-meter length of 18-inch 0.46 meter. Diameter purge at 24 and 1 minute would be this equation. Followed by this equation, a general rule is to be pre-built per as flow rate and time that will produce 5 to 6 volume. In the example above, one volume change occurs approximately every 42 minutes. 6 changes would require 252 minutes or about 4 hours. Figures show minimum pre-built purge time in minutes per 12 inch of pipe for varying pipe diameter and 24 liter minute flow rate. Suggested pre-built purge time can be found quickly and easily from the graph. This is graph. Purging prior to welding, while the use of calculation and graph such as these discussed above can simplify estimated for pre-built per application. It is recommended that the residual oxygen level be measured prior to maintain of welding. This can be done quickly and easily with commercially available oxygen analyzer. Which are accurate and easy to use for steel and nickel alloy, and oxygen level of 1% or lower is usually adequate. Reactive metal such as titanium will require a lower oxygen level. Purging during welding. Once the required oxygen level inside the pipe has been achieved, the flow rate of the entering purge gas should be reduced before root pass welding, being in order to eliminate excessive pressure on the inside of the pipe. Excessive pressure will cause unacceptable root surface concavity or hole through the root bed. The proper purge flow rate during welding is one of these barely detectable at the gas exit period when welding with the consumable insert, where the unfused insert service to cell to root and prevent the escape of gas. Flow rate on the order of 12 to 8 to 12 cph, 6 to 46 liter minute are required in the usually necessary to reduce the flow rate. Reduce the flow rate at the root is close to prevent blowout or welding. However, flow rate will be required for open groove welds. For small diameter piping or tubing, it may be necessary to reduce flow rate below the valve recommended above. It is usually described to maintain the path for the second and third layer of the weld deposit to minimize internal oxidation during reheating of the root path. Thick welding is important to root path welding. It should be done with care because of the tack weld normally become part of the final weld. For this reason, tack welding is not usually performed until pre-weld purging has been complete for the those material required purging. At last, for tack weld should be made at 90-degree intervals around the pipe for 10-inch and larger diameter. Tack should be made at large every 6-inch around the pipe, and they should be enough to resist well shrinkage force which will be try to pull the root close. When welding, stainless steel tack should be spaced more closely. Tack weld should be checked by the welder as we progress to be sure that they remain intact. Tack weld should be cut fully ground out before the proceeding. Tack weld should be clean period to be root path welding. For open root weld, both ends of the each tack weld should be carefully ground and entrapped to promote complete fusion of the removal of the root phase. During root path welding, if the root path welding is not made immediately after the tack weld, care should be taken to protect the joint and maintain the cleanness. Thank you.